Welcome, everybody. We're going to be working on the Unit 1 textbook materials today. We did get a head start last week and completed, or at least looked at the W3 pre-tests, the personal project planning. We'll circle back to this and talk about that a little bit more. We also did the file management thing, if you guys remember, and we did the simple FTP upload. We did a lot of stuff last week, right? And I will talk about all of these topics again. And I will just kind of reiterate, if you're having issues with any of this working, please reach out to me for help. I'm happy to do so. For right now, let's make sure that we're addressing the textbook that you guys went ahead and purchased, right? Because you buy the textbook and it's like, man, I spent all this money on the textbook, so we better use this thing. So yeah, we're going to use it. As I've mentioned about this particular author, this author seems to be a Wisconsin native, because all her places that she does websites for as samples in the book have Wisconsin addresses, which I think is kind of interesting. She also is a very good writer. I think her style is really clear, informative, easy to follow. And you know what? I think I'm not going to do this through the browser here, and I think it's kind of silly to say it like that, but I'm going to switch and load up a version from my drive here instead. That way I can more easily go full screen and not lose the browser interface. All right, so here comes the chapter 1 PowerPoint. You can download that PowerPoint if you care, or you can just watch my screen here and watch the video. Either way, in some cases, I do find that with some authors, right? And this author is one of them. In some cases, you can kind of look at the PowerPoint and almost skip the book, because the PowerPoint's got such good information. It's put together well. I still tend to have this tendency here of trying to fill in the blanks, like sometimes, like, there's book knowledge, frankly, folks, and then there's like the practical knowledge of doing it for real. And I'm going to kind of pepper that in as we go. Like to say, hey, the book says you should do it like this, but hey, what we really do out in the field is we just do this, that kind of thing. And I want you guys to be aware of that, because ultimately, if you're going to be doing it for real, you need to know like those types of things as well. All right, so here is our little title page here. And as with every chapter, and authors do this, we do this when we design courses, we have a list of topics that we're covering. So this is the stuff we're going to learn here, right? This is some interesting topics. Some of them I will look at very closely and deeply. Other ones I'm going to I'm not going to say gloss over them, but cover them in the amount of depth I think is appropriate at this level in the course. Not that it's necessarily unimportant, but sometimes you need to get a little more under your feet before you look at certain topics, in my opinion. Let's talk about, what is the internet? All right, so this is like something we just use every day. It's there. We got Wi-Fi, we get hardwired, we got it in our phones, so we can do it through cellular. There's so many different ways to do it. But what actually is the internet? And you know what? There's really cool videos out there. Like if you just like Google it, or like look up on YouTube, the history of the internet, or how does the internet work, those types of things, you can find some really good information. But generally speaking, when you think of like the network you have in your own home, right? You got a router and Wi-Fi, and you might be hardwired or you might be wireless. And inside your house, you have a network. And then the way you get on the internet is that router, or whatever device your internet service provider gives you, that has a connection to the outside world. And then everything that's on your internal network connects to the outside world through that device. Usually most of us will have, either a cable router or a digital box that comes from AT&T, depending on the type of connection you have. Ultimately, where does that go? People, like, hey, it works at home, I don't care where it goes. But the reality is you're connecting to somebody else's private network. So when you pay for Spectrum service, you're connecting to Spectrum's network. And then if you're paying for AT&T, or if you're doing like a Verizon hotspot thing, you're getting on their network. And then however that network is put together, right, they have their own wiring schemes. It could be through a cell tower, it could be through fiber optics, it could be through copper, or all of the above. That connects back to their central locations, which then goes out to the internet, right? Okay, well, now what is the internet? The internet is basically a whole bunch of private networks connected together over public wires. It first used to travel over our phone lines. I think that's kind of fascinating, right? Because our phone lines in the old days were twisted pair copper. That technology is still heavily in use. And in some places, that's still the only way to get your internet. And in fact, most Spectrum customers pull it down over their cable line. What is the cable line made out of? Yeah, copper. There's one strand of copper in there that carries all your internet, all your TV channels, and maybe your phone too, right, over one piece of wire. It's pretty amazing, actually, when you start to think about it. But ultimately, what's really going on is the internet is a network of networks, and all of it is owned by somebody, but everybody wants to be able to connect to each other. So they make certain segments of their network public. And so we have this thing called like an internet backbone that kind of connects us all together. And in principle, all the countries in the planet have free access to the internet. What you will discover, though, is if you start digging deep, that's not actually true. There are countries that do not have free internet access. And I don't mean cost. I mean access to everything on the internet. This is kind of an interesting thought. Now, if you come to Gateway and you're on our network there, let's say you try to do illegal software download. I'm just throwing something out there. Or you're trying to look at like pornography. Gateway's network will block you. We have security things in place that will not let you do those things. It just won't happen, right? But the free and open internet, if you're paying for it at home, you can do whatever the heck you want, legal or illegal, or moral or immoral. That's up to you, right? You're controlling that. But there are countries on this planet that don't have that freedom, believe it or not. Really great example, China, 1/4 of the world's population does not have free access to the internet. It is tightly controlled. People in China cannot Google. How do you like that for a concept? Right? They don't want to pollute the minds of their people with Western thinking. Kind of an interesting thought, kind of crazy, but totally true. They control the internet there. So the internet has been around, and this kind of alludes to the fact that, okay, well, it started in the 90s. False. It started in 1969. The first connection of the internet was from UCLA, Berkeley, or was it Stanford? I forget. It's Salt Lake City over to California is basically what the first connection was. And from there, it grew exponentially. We had basically universities, military, and government first came online, connecting their systems together. And then later on, a bunch of private networks formed that then also bought into the internet and connected, and it just kind of expanded from there. By the late 70s, early 80s, all the things that we're accustomed to doing on the internet were already happening. Email, chat, gaming, file sharing, social interactions, threaded conversations like Reddit, all that kind of stuff, all of it was happening by that time, right? Just the problem was the majority of the world wasn't on the internet. You had to have a really expensive equipment and gear and know-how to get online. And getting online was literally done through phone lines. We used modems that worked really, really, really slow. And I'm trying to emphasize that. And I'm talking like, my first modem was like a 2400 bits per second. And now we're getting hundreds of megabits in download from our internet service providers, very different lay of the land. Now, a bunch of reasons why the internet exploded in the 90s. The first reason is basically the technology improved significantly. And people started becoming aware that, hey, I can buy my own computer. And, oh, hey, there's this modem thing. What do you do with this? Oh, I can connect to the outside world. But you weren't really connecting to the outside world. In many cases, what you were really connecting to is a private bulletin board service. For example, AOL or CompuServe or Prodigy. I'm trying to think of all the major players back then. Those are kind of the big three. And then there was local players, like here in Milwaukee, we had this company called Exec PC, and that was like the go-to for getting onto a bulletin board service in Milwaukee. Initially, none of those services actually connected to the internet. This is what's weird. It was a closed system. You could interact with the people on that system, look at stuff that was posted on that system, but that's kind of all you could do. When those systems started to interconnect, though, then the internet really kind of took off on a consumer level, but it was often an upcharge and it was pretty expensive. By 1990, you'll notice that first bullet there, they decided that, you know what, it's okay if we use the internet to allow companies to use the internet now, right? So up until that point, it was only government, education, private users, and the military basically that use that system. Then they lifted the commercial ban, and within years, people were trying to get up there figuring out, hey, how can I sell stuff on here and make money? You know, and then you saw the birth of Amazon and e-commerce and things like that. Now, the person who really kind of did this really amazing thing and really, like, if you ever hear a thing that says Al Gore invented the internet, false. That's not true. You know, he, I think, invented the term information superhighway, you know, in a speech or something. But the person who really invented the World Wide Web, which is different than the internet, it's the World Wide Web is basically a virtual construct that we use to surf the internet, meaning that to connect to any device on the internet, we have to know the IP address, the numerical address of the machine in order to attach to it, right? Then what happens, you know, from our standpoint is we can't remember numbers to connect the computer. So what they do is they basically assign domain names. So like Coca-Cola.com is a great example, right? And what are you really connecting to? You really don't know. It's a virtual construct. What Tim Berners-Lee brought to the table is he would connect, you know, academically, say, hey, if I need to get these files from this research institution over here, I have to know the FTP address, and I got to get a login from the admin, then I can log in and download the files I need. But wouldn't it be much better if I could just go to this screen and click this link and just get it? Right. And so he came up with the idea of the web browser, that we could have this piece of software where I don't have to know all the technical details of how to connect specifically to any machine, but I can just click on something and just go there. That was the magic that he brought. That was called the World Wide Web, right? Because he was linking together these things that previously were a bunch of separate systems that weren't connected together. And by symbolically like attaching to them, it made the internet usable for regular people. And it did not take long for it to explode. Here's some really interesting history too. When we, you know, we always think about, like, when we're thinking about like important computer stuff being developed, we never think that, hey, none of that happens in Wisconsin. I'm going to break your notion of that. It sure the heck does. This third bullet, the development of Mosaic, the first graphical web browser. And you know what? You can Google that. I know the book's got a picture of it. Right. This is what it looked like, folks. We'll just do some images. It's probably fine. It was very, very primitive looking when it came out, but that was kind of the killer app that brought it all together. The interesting thing is when I was first on the internet, it wasn't the Mosaic browser. It was the browser that Tim Berners-Lee developed, which is called Lynx, Lynx. Mosaic took the code from Tim Berners-Lee and then built the first graphical browser. The two guys that wrote the code for this were going to school at the University of Illinois in Urbana-Champaign, down Central State, because they have the National Supercomputing Center basically attached to their school. Those two guys were from Wisconsin, by the way, right? And they wrote this as part of like a school project. They wrote this software, right? They took Tim Berners-Lee browser and they made it graphical. Now I could load it up inside of Windows or the Mac OS, use my mouse and move around and click on things, and I'm magically going to all these places on the internet, right? So that was the first graphical web browser. All the other web browsers that followed were built on top of this. They used this code to build what they had. And these guys used Tim Berners-Lee's code to build that, right? And this is what happens. These two guys went on to basically take that browser, and it became before it was Firefox, what they call it before, it was Netscape, right? It was Netscape before it was Firefox. And so they developed the Netscape browser, which they gave away for free. And where they made their money was by selling the server that would run the web pages to send to Netscape. So they would sell server software to big companies, and then we would connect on the internet to the servers through our Netscape browser. And at the beginning of the internet, Netscape was the thing. Totally, right? There was no Internet Explorer, there was no Google Chrome, none of that stuff. Eventually, Netscape got purchased by, I think, AOL or somebody like that, and there was like these browser wars that were happening. Microsoft was developing their browsers too, but ultimately, that's where all our modern browsers come from, is from those two guys from Wisconsin, which is kind of cool, right? When you start to think about it like that. Computers were getting pretty cheap at the time. And in 1995, when Windows 95 came out, and we had all these online services already in place, and Windows 95 was built to get on the internet right from the get-go. It had a browser built into it. It exploded. 1995 was the year that people started to go online from a general consumer standpoint. By the year 2000, most people that had enough money to own a computer were also online. That was about 70-80% of the country had an internet connection in their house. What's the percentage now? I mean, I don't think there is a house that doesn't have it. Very, very few, right? Got to be living in Alaska off grid or something. All right. Lots of stuff going on. So like you can take a look at this little graphic here, but a lot of stuff that kind of led to it. And that's kind of what the previous little talk was about, is like the technology's been there for a while. Somebody figured out a better way to connect it. Somebody wrote the killer app that made it easy to use, and it got built into our operating systems, and the price of everything went down. Of course, it took off. And then once you're on there, you go, oh, this is really cool, right? And I remember having early internet connections, and folks, there was not really much to look at out there, but I could just sit there for hours going, where does this take me? Where does this go? This is so cool. That's all I would, it was just amazing, right? We take it for granted now, but it was kind of like that at one time. The World Wide Web, and it says here the graphical interface to information stored on computers running web servers connected to the internet. Okay, so that's really back to the Tim Berners-Lee thing. We don't need to know the nitty-gritty of how stuff connects. It just happens in the browser, and we just see it on the screen. And it's very, very visual compared to, like, if I was to do like this kind of a thing, right? Bring up a command prompt. The first time I looked at the internet, it looked like this, because the Lynx browser that Tim Berners-Lee made was a command line browser. It still exists, by the way. But yeah, not very pretty compared to like a windowed environment that we use now. The internet is an area. So like, we have to apply standards to it. So this is really kind of a weird thing, but how do you communicate with somebody somewhere else if you don't agree upon the method of communication? Like, for example, it's implied, right? We are in the US, so you guys are coming to college. It's kind of implied that we're going to speak English, right? So we all agree that, hey, you're coming to school, we're speaking English, right? If I went to school in Mexico, we would speak Spanish, right? It's just a given. So the internet has rules too, to like how the languages and the communications happen. And we have a bunch of different standards bodies that oversee how things connect together. You don't have to memorize any of this stuff, by the way. But look at the acronyms. This one, however, is one that you will run into. ICANN, whenever you go out there and you buy yourself a domain name for a website, for example, there's always an ICANN fee. ICANN is an organization. It's located in the state of North Carolina, where the master domain name database for the internet resides. It's kind of interesting. Up until about 5-6 years ago, somewhere in that range, maybe even 7, ICANN which was up until that point in time completely controlled entirely by the United States. So we were in control of the internet, folks. It got converted over to an international body, but the body still resides in the United States and all the main systems are still here. But now there's international cooperation, right? So I think people were pointing out the fact that, hey, why should the US have control over all of this? That's not fair, right? And they're right. But the flip side is we should all be thankful, by the way, that all this technology was developed here in the United States, because when we write code for the web, we do it in English. And this is really fascinating. If I go to a Chinese website and bring up a website, they have to code in English too. They can't code in Chinese. Why? Because the tech was developed in English. So can you imagine if you were in China and you had to learn your HTML? First, you have to go to English class for a couple of years to learn your English. Then you can learn how to code. To talk about a barrier to learning. Can you imagine if I made you guys learn Chinese first and then you can learn how to make web pages?
Imagine
Most
if it was in Latin.
Yeah, you would drop out probably. I mean, I think it's pretty hilarious, but that is the truth of it. Now, I can, once again, these are the people that control all these things. So all the domain names on the internet, like whatever.com, right? The IP addresses that those domain names resolve to, and then all the protocols and the port numbers that the internet uses to connect. They oversee that, right? It's not an unimportant thing. So basically the master database that tells people's computers where to route their traffic to the right computer on the internet is here in the United States in North Carolina. Pretty cool, right? The database is replicated around the planet, I believe 13 or 14 times. Why? What if a bomb dropped on North Carolina and took it out? Internet would go down. So you replicate that information, you put it all over the planet, and the internet will never go down. That's another scheme of the internet, by the way. This is kind of an interesting chart. It caps off at 2019. So it would be kind of nice if it went beyond that. I suppose you could follow that link and do it. But the grand point is, in 95, when the internet just started to come out to the general public, basically, hardly anybody had it. I am proud to say that I was part of that 0.4%. Right. I was already working in IT by that point. And then in the year 2000, look how much it jumped up. I mean, now 5-6%. In 2019, right, this is a percentage of the global population. This is not the US. This is the global population, 56% by 2019. Would you think that should be higher?
Yeah. I was surprised by that because I read that. And seeing that, I thought that was kind of low, in my opinion.
Right. But here's what we take for granted here. We take for granted that in the US, everywhere we go, there's electricity. Everywhere we go, there's cell service. Everywhere we go, there's phone lines. And, and if there's not, we're all like miffed about it, basically. There's plenty of countries that, first of all, don't have the economic power to do what we do. They have huge portions of the population that basically don't earn any money or very, very little money and can't afford to do it. And then even if they can, if they are getting on the internet, that 56%, a majority of them are on a cell phone. And the reason the internet's kind of exploding now in third world countries, and think about this, here in the US, if you want to get internet, well, Spectrum's already got lines going down your street, right? All you do is pull it from the alley or the street over to your house, connect you up, and you're up and running, right? The wires are there. But if you're in like India, where they have huge, people in socioeconomic conditions that are not great, and they're living in basically shacks compared to what we live in, right? It's like even the poorest people here in the US live like kings compared to a lot of people around the planet, real frankly. What they do there is now they just throw up a cell tower. They give people all these like cheap burner phones and stuff, and they're up on the internet. They don't have to run any wires. That's how most people on the planet are getting on the internet, is on their phones. And it's really kind of critical. All right. So Monica, thank you. Okay. 63% of the world's population is online. Okay. So we have to qualify that a little bit. So think about this, and thank you for throwing that in there. I appreciate that. So the number has grown a bit, right? So the chart keeps growing. But think of how many people on the planet. If there's like 8, 9 billion people on the planet, how many of those people are children? Like, I don't know, under
Sure.
5. Yeah, right. And then think about this, like the younger people here. At what age did your parents allow you to have either a phone or a computer that you could use or a tablet or whatever? I mean, I got my kids online pretty young, but
It was
I know for a lot of you, like parents who care, they're like, you can't be on the internet until you're 10 or something, right?
it's different nowadays. I know for me personally, I didn't get my first cell phone till like eighth grade, ninth grade. And nowadays, I got little nephews that got their first cell phone in first grade.
Yeah, right.
Yeah.
Well, I mean, I understand, and I think Juan, like you're in that situation. My kids were kind of somewhere in between, and the only reason they got phones is because like sometimes like we weren't within proximity to pick them up or something, and it's like, okay, if we're not there, call grandpa, or something
Yeah.
like that, and you give them a phone. Of course, they couldn't use it in school, but basically what they got is their hand me down flip phones and
Yeah.
stuff, but they had phones, and to this day, and I told them the ones that you guys have now is the last one I'm paying for, because now they're in their 20s, and it's like once that one breaks, you buy the next one's on you. You're working, you pay for it.
Yeah.
But yeah, I think that's a part of it. But there's also a lot of people that are older, I think, right, that don't touch phones. Now I'm kind of an old guy, right, but I'm fully technology embraced. I have friends who are like, yeah, I'm on my phone once in a while, but that's it. I don't want a computer. I don't want the internet in my house, like that. There's people like that. I respect it. Um, I think that's changing a little bit though.
Yeah, I
A
mean, my
lot of
grandmother had
different.
a flip phone up until she died.
Hey, you know what? The nice thing about a flip phone is you actually use it to make phone calls.
That's
Right.
I don't know about you guys, but when I use my smartphone, the last thing I use it for is phone calls.
true.
I mean, mostly it's like games, sports, news, weather, some
I mean, to get a
game,
hold of
whatever.
work-related stuff, it's easier to call them because they'll actually answer. You
You know,
text them, you're looking at 6 to 8 business days before you get a response. You call them, they'll call you back within a few minutes, freaking
yeah,
out. Like,
it'll depend
"Mhm."
on who you're talking to, for sure. All right, let's keep moving forward here. So we use this word internet, right, which is a network of networks. And then there's this construct called an intranet, to not confuse the two terms. I'll give you an example of an intranet, right? So when we're working within Brightspace, we're all signing into a system that's kind of out on the internet, but you can't really access the real stuff in there until you log in. Once I'm logged in, now I'm inside this kind of like virtual construct that's inside of a network, right? Not everybody has access to it. Like, for example, not everybody has access to this course, just you guys and me, right? Or our system admins do too. But that's kind of an intranet. It's a private construct. Then you also have an extranet. And so this is where the area gets kind of a little gray, I guess. So sometimes you might be, as a company, you might give outside organizations access to your internal networks. Okay, so the question is, why would you do that? Well, very good reasons. For example, if you guys ever use a VPN service, I don't know if anybody does that kind of stuff, but for example, when we do high-end IT stuff here in this program, like for example, if you take the Java 2 class and we remote connect to a database on campus, you guys first have to VPN the campus, which means you can't connect to that database unless you're on the campus network. So the extranet is basically allowing you to connect to the network externally, even though you're not there, to access the internal resources, right? In this case, a database, so you can do your homework. So that's kind of what an extranet is. Now, we took a look at that W3 Schools site. W3 Schools is run by this organization, the W3C, the World Wide Web Consortium. These are the guys that make the rules for the languages that we use to code the web. And I think I told you guys this last time, right? W3 Schools is the place to go for HTML, CSS, and JavaScript, because they're the ones that basically, I'm not saying they create it, but they create the rules for everyone to follow. Let's think about this. If we all spoke English, but, hey, you speak the Queen's English, I speak like, I don't know, California English, or, whatever, or Australian English, they're all a little bit different. I mean, British people spell some words differently, right, than we do, even though they're the same word. And then I had a British friend actually visiting, what was it, 2 weeks ago? He was in town, and he's like, I don't know, what's the weather like there? Should I bring my jumper? I'm like, he must mean shorts. You know, jumper must mean shorts. But then I discovered, no, a jumper is a hoodie. You know, like, he wasn't sure if he should bring a jacket, basically, because it's Wisconsin. Is it going to be cold? And I said, oh no, man, you should totally bring your jumper. I got schooled, right? Because we didn't speak the same language. You know, we know what we're talking about, but we speak a different language. So when you agree to a rule set, it helps, right? There was a time, like when browsers first came out, basically that nobody followed the rule sets. Everybody had their own. Microsoft had their own rules. Netscape had their own rules. You'd write a web page, look great on the Microsoft browser, to look horrible on Netscape, or vice versa. And sometimes you'd have to write code that would go, which browser is being used? Okay, give them this code. Horrible, nightmarish stuff, right? That's when I first learned. And now what's basically happened is all the browsers are following standards, and they're kind of quietly incorporating new features at the same time. We are in, I'd say, a very easy to design for era of the web. One thing that's a big concern, and we face this like when I put my course shells together, is accessibility. This is really kind of a weird thought, but we naively think when we use the internet that everybody can see and hear and have all the same senses and sensory inputs that we do. It's not the case, folks. There are people that are blind that use the internet. There's people that are deaf that use the internet. Heck, there's people that are both that use the internet. So it's like, how do they do it, right? There's all sorts of gadgets and devices that they've created to allow people to surf the web. You also get people that have maybe a little bit not so severe disabilities. For example, I have had students in my classes who are just very hard of seeing. They're not blind, but they have to like zoom their screen like way the heck in, or turn off all the colors. It's got to be high contrast, that kind of thing. And it's not abnormal. There's a lot of people that have those issues. And guys, I hate to break the news to you, men are very apt to become colorblind, especially with older age. Like, we can't differentiate our greens and our blues, like, is that green or blue? I'm not really sure. And you might see it as a completely different color. So this matters when you're designing a web page, because if you know that your audience is going to be deaf or blind or hard of seeing or whatever, you can design the web page to be optimal for them, and you take them into consideration. There's plenty of deaf people, for example, that use screen readers. I've had students that do that, where, they go to the web page and they have a piece of software on their machine that just reads the page to them. So you better put some words on the page. There's another kind of weird thing. There's a lot of movement, right, to, if you ever get hired, right, and it's a possibility in your career that you might get hired to build web content for government or government affiliated websites. So for example, our webmaster here at Gateway may occasionally have to adjust pages that he's creating so that he can make sure that people with disabilities can see them. Right. There's some challenges to doing that. So it's like you can build the whole site and then you have to maybe rebuild it to make it. There's rules that they follow, and that's what this link is about if you want to dig into that. I'm not getting too deep into that. I don't generally worry about that too much. I worry more about general aesthetics, at least at this level. But when you get into working for government design principles, they will point you to this thing, which is the universal design. So the idea is that the stuff that you create will be accessible to everybody with one page created. In the old days, we would sometimes like, oh, if you're on a phone, we'll just give you this page. If you're blind, we'll give you that page. These days, the goal is one design, one universal design that will accommodate and automatically adjust to everything, right? That is actually pretty challenging to do, but doable, right? All right, it's just a silly graphic. All right, skipping over the questions and the checkpoints. All right, so we talked about the internet, and we talked about networks, but we didn't really talk about what a network is. A network is really a bunch of computers connected together. Simple little diagram, right? So this might be kind of what you're home situation is like, maybe not, maybe a little more complex or less. Most of you probably don't have a server. Some of you might have printers. I'm going to bet, most of you have a computer or two, and maybe a laptop, and maybe a tablet, and your phone, and your game system, and your Roku, and your Ring doorbell. Should I keep going? You know what I mean? We have so many devices now. Sometimes I look at like my router, like IP page, like all the devices connected. I go, when did we get like 60 devices in the house? But I forget the fact that I got my wife, my two kids, all of us have a ton of stuff. All of us have at least two computers, and gadgets. It's amazing, right? So our networks now have gotten pretty complex. I've also in my house gotten to the point where I have my separate cable modem, which I own, not the cable company. And there's a hack for you. If you use Spectrum's cable modem and router, you pay for that every month. There's a kind of the old phone company stand. They would give you a phone, but they would make you pay $1 a month for a phone. And if you kept that phone for 50 years, you paid like $10,000 for that phone or something insane. So what you can do with at least Spectrum is you can buy your own cable modem and then hook up your gear to it. They will remote control it though, but you own it and you don't pay them for it, and it saves you like $5-10 a month on your bill, by the way, and you can get better equipment than what they give you. Another good hack. What I do at home though is I have my cable modem, I have my main router, and then I have two auxiliary routers because the one router isn't enough to cover the whole house with Wi-Fi completely. So I have 3 of them in the house now, right? I don't know if you guys have networks like that too, but we also have a ton of devices. Some terminology things. You guys hear these terms all the time, probably. Hey, it's a LAN, right? Local area network, usually stuff within one building, everything in your house, or if we were at school, everything on the 3rd floor of the Racine building or the technical building is all one local area network. A wide area network, of course, is when you take those local area networks and connect them over a distance. Gateway also has this kind of infrastructure because we have, I think, 9 or 10 campus locations. We have Racine, Kenosha, Elkhorn, IMET, Horizon, Burlington. I'm not thinking of the others, but there's a whole bunch of them. All of them are on the same network, but it's done over a distance. So we pay for private connection lines so that our networks, like if you're in Elkhorn and you need to hit the registration system, which sitting in Kenosha, you can do it and you don't have to leave the network to do it, right? And that's a wide area network because it's over a distance. A lot of companies operate like that. The internet has what we think of as a backbone. There are actually maps of the internet, but this is growing at an exponential rate right now. We have some of the best infrastructure in the country this way. We have probably more fiber optic backbone than most areas, excluding maybe California and East Coast locations. We benefit basically by being next door to Chicago, right? A lot of traffic routes through here, and our networks are really very excellent, and our bandwidth is very good. If you guys travel and you end up like, I don't know, I'm not picking on a state, but maybe like in Omaha or something like that, you might find that the internet is not as great as it is here. We're actually pretty spoiled here, in this part of the world, and that's okay. I'm fine being spoiled with fast internet. There's kind of these concepts that we talk about, and we talk about this concept of client and server. And basically a client is a computer or something on the internet that generally is consuming the information. Like when we're using our laptops or our phones, we're generally clients. A web browser is thought of as client software because it doesn't really contain the content. It's just receiving it like a television set, right? That content's out on the internet. Where is it? It's on a server. Like, for example, Prometheus. We uploaded stuff to Prometheus, so that's our server. And then we look at it in our browser. The browser is the client. So when we learn how to code in this class, what we're really learning how to do is we're learning client side. This is what they call it, client side coding. Because what happens is we send the code to the browser reads the code and does what the instructions say. It says, okay, put it up put it up there, make it blue. And that's what happens on your screen. The browser follows whatever the code says. And the browser is the client. The server receives a request from the browser saying, hey, can you send me this page? The server goes, oh, you want this file here, the one that you uploaded last week. We'll send it down to you. It reads the code and it does whatever the code says. Loads the images, makes the color, sets the fonts, determines the layout, the words, everything on the page, right? But the client is receiving, right? And so you can see, like, you know, what this says here. So connected to the internet when needed, usually runs a web browser, the client software. So they're pointing out Edge and Chrome, but don't forget Firefox and Safari and Opera and Brave and yada, yada, yada. There's lots of browsers out there. There's more than just Chrome and Firefox and Safari, folks, and Edge, right? There's more than those. The protocol that the internet uses to deliver web pages is HTTP. We talked about that, right? That's the beginning of every web address, even though most of our web browsers now kind of obscure that. And it's either HTTP or HTTPS. There's a really big move that was really kind of spurned by Google, frankly, because Google started deprioritizing search traffic that wasn't HTTPS, which is secure, right? So the information is secure in transit. In the old days, we used HTTP because, hey, you're just looking at sports scores. Who cares if that's secure? You know what I mean? Or you're just sending a silly message to your friend. Does it really matter that it's secure? But now basically any website you're logging into is HTTPS. Prometheus is HTTPS. And what happens is if you hit a website that isn't, you start to get warnings in your browser saying, this website's not secure. It's unsafe to proceed. We recommend you go away, right? And at the bottom, if you look really closely, it says, proceed to the location, assuming all the risk or whatever. And like, if you know that it's your server and it's insecure and you're connecting to something that's okay, you do it, right? But if you don't, you probably shouldn't. And you certainly shouldn't put your credit card number on that machine, right? Or that website, absolutely not. But generally speaking, the client makes requests to the server for a page, say, hey, send me the page, and the server sends it back, and then it reads it and puts it up on the screen. The server basically sits there on the internet all the time. Prometheus does this, well, you know, as long as it's running, right? We have had a couple of outages here and there, and it just sits there running a piece of software called Apache, or if you're on a Microsoft server, Internet Information Services, or IIS. There's other web server software. Those are the big two. The other notable one is called Nginx, Nginx. And those are just software that runs on the server whose job it is to receive the requests and pull up the correct files and send them back to the clients. Yes, Juan.
I got a quick question with the server. Do you have to use one of those softwares in order to have that server continuously running? Or are you able to create your own server to host your other, you know, your other computers or stuff like that?
Yeah, well, you know, that's an excellent question. So the server, you know, a server, and Prometheus is one of these machines, right? So Prometheus is just a computer running an operating system. The operating system it runs is called Ubuntu, which is a variant of Linux, right?
Okay.
So without web server software running on top of it, if you try to query that server for a web page, it would do nothing. That software has to be running on port 80 to receive the request and then send them back. Now, at the same time, that Prometheus machine is also running an FTP server that allows you to upload your files. It's also running a database server that allows you to create databases and use them to power your websites and a bunch of other things, right? So that server, like your regular computer sitting in front of you, can do many things simultaneously. Even your computer sitting in front of you can be a web server if you install the right software, right? And yes, if you're thinking, well, then can I make that accessible to the internet? You can. I wouldn't recommend that, but you can. You have to really know what you're doing before you do that, right? So great question though. Yeah, so it's that piece of software. Most typically, you know, most of the internet runs on Linux. Most of the web servers are Apache or Nginx, the software that's handling the requests. All right. So we have this MIME type that allows us to transmit multimedia documents. It used to be designed so we could send email, and then this kind of converted and allowed us to send audio and video and streaming and stuff. It's not something we really talk about a lot as a technology. Nowadays it's like, hey, videos work, audio works. It works. We don't think about this, but in the old days we used to have like plugins and doodads and things we had to do to make it work. So like, for example, if I wanted to watch a video, it wasn't a given that it would work. If I wanted to listen to like an MP3 file, I was on Firefox, MP3s didn't work in Firefox, WAV files did, etc. So we had all those plugin problems. We've overcome that now, I think, as a general rule. There are the protocols, right? So HTTP is a protocol, FTP is a protocol, email is a protocol, and there's a whole bunch of other ones. In fact, there's maybe thousands of them that run over the internet, and they're basically just rule sets or an agreed upon standard for how you're going to communicate, like how we speak English, right? You speaking the Queen's English, or you speaking American English? Are you? So we agree to follow the same rule set so that we can talk. And there's a bunch of protocols, and some of them are very specific to certain tasks. Some of them have been around a really long time, but there's new ones being developed all the time. One of the real important ones for us, obviously, is FTP. This is the one that we've already played with a little bit. This is how we upload our files to web servers and download files. Why do we use FTP? Because FTP is faster at moving large files than HTTP is. Why? Because it has less overhead in the packets of information that travel over the internet. So if you're going to download like a movie file that's like 8 gigs or something like that, FTP is the way you want to do it. It's going to go way faster than HTTP, because there's moving less data ultimately. Email's also a protocol. And if you guys have ever done any email configuration, you might be familiar with like SMTP or POP or IMAP, like maybe sending up email on your phone. Although these days, once again, they've kind of dumbed down the process. You get your phone and you say, which email you use, Yahoo or Gmail, and it just works, right? In the old days, if we wanted to connect up email, we'd have to know the settings for these protocols. Well, is your incoming a POP or is it an IMAP? Right, IMAP is really the one we use these days. In the old days, POP was the more popular one. SMTP is the protocol that we use to send mail. Yes, Ron.
So what handles like traffic to a website? For example, like Amazon, say you got 5,000 people online checking out all at once. Is that server has to be able to handle that much traffic, correct?
Or is able to take the traffic and route it to other servers.
Okay.
So what? Yeah. So you're asking some pretty key questions here. So these are really more like networking questions.
Yeah.
But I mean, you can't make the assumption that Amazon has this one really, really big computer that does all of it, right?
You got more.
There's a whole bunch of them, and then you have ones that sit in front of it that say, okay, well, this server's busy, you go to that server, right?
Okay.
And the traffic routing. But that it is a really valid concern though, because if you have a low-level website, and this happens to websites, like, hey, we have like low-level hosting because that's all we need, and all of a sudden something on their website like goes viral, and everybody's hitting it all at once, and the website goes down because it can't handle the traffic.
Yeah.
Amazon, however, has technology in place for their systems that automatically scales. So if like it's Christmas, and more people are buying on Amazon, I don't know if they do it manually or automatically, but it's upped. Same thing. Think about it like this: the NFL, most of the year, let's say between like February and July, there's not a lot of traffic on their website, but the season kicks in and they ratchet up their services. They do it on Amazon, by the way. And then when the Super Bowl hits, they like triple that or quadruple it, because all of a sudden everybody wants to watch the Super Bowl.
Yeah.
Right. And then the moment the Super Bowl's down, they dial it back down, because then nobody cares.
Yeah.
Right. At least for a few months. Right. We switch over to basketball. All right. So we talk about HTTP, and basically, I think we've talked enough about this, the requests and the return from the server. HTTP is the protocol. It's hypertext. I think really interesting concept. Even the word hypertext is one that was invented I always forget the dude's name, but he thought of this concept back in the 40s. And he's like, I'm reading this book. Wouldn't it be kind of cool if I had a book where, like, if I didn't know like the meaning of a word, I didn't have to have like a dictionary sitting next to me. So I'd have to like, hey, what does internet mean? And then you pick up the dictionary and you're looking for it. Like, wouldn't it be cool if I could just like touch the word somehow and it would just tell me what it is, like a built-in definition or something? And holy cow, I mean, that was one of the inspirations that gave Tim Berners-Lee the idea to build that first text-based web browser, was that concept. Hey, I can just take the word and I can touch it or click it or whatever, or activate it, however he did it with the keyboard. And then that will take me somewhere else and give me the information I'm looking for, rather than me having to manually find that resource and pull it up. Right, so that's where the concept of hypertext comes from. Now, the networks that are operating work over the top of what we call the internet protocol and the transmission control protocol. So the internet protocol, and we call this, as a networking thing, TCP/IP, and the IP part of it is the internet protocol, or the numeric addressing scheme of your computer. And I'm going to give you guys just a really quick little example. I'm doing it from a prompt. I know I can do this from a settings window, but in Windows, I can go to the command prompt and type ipconfig. And if I'm on a Linux system, of course, you type ifconfig, max the same. Or you just go to the networking control panel and there's a thing that tells you it too. But I'm old school, so I just kind of go this way. Usually it's faster for me. But it shows me all of my network adapters, and there's a whole bunch of them because of the weird setup I have, and the IP addresses of the devices. And this is an IP address. This is my IP address internally here on my own network. So if a different machine wanted to communicate with my machine inside my house here, they need to know this number to hit this machine, like transfer a file or whatever. Right now, my machine doesn't have like a, takiskinis.com attached to it, right, inside the house. So if I wanted to hit this machine internally, I have to type that number. That's what the IP is about. IP is the numeric addressing scheme of the internet. TCP is the error control and software layer for the network. So we run software that goes over TCP that makes sure there's no errors, that everything was delivered as it was intended and put back into the correct order, right? And this is really kind of a fascinating thing about sending stuff over a network. When we send stuff over a network, like for example, if I take, let's say, the screen that you're looking at now, and I screen capture it and it becomes an image. If I'm going to transmit that image to you on the internet, the assumption is kind of like I'm putting a letter in an envelope and putting it in the mailbox and sending it to you, and you get it all in one piece. That's not how the internet works. The internet takes that picture and breaks it down into a bunch of little, what we call packets of information. So it chunks up the data, and then each chunk of data has like a letter does, from and to, and then a little checksum and stuff. But that packet travels independently over the internet. So we might break this image into 1,000 pieces, cast them all out onto the internet on their own to get to the other side, following the address on that packet. And then when it reaches the other side, it's reassembled. And think about this. You hop up on the web, you click on something, and if that thing doesn't load like this, you're angry, right? It's taking like 2 seconds to load that image. What the heck's going on? Meanwhile, the thing's being ripped into pieces, delivered over the internet. The pieces might not even take the same path on the internet to get there. They're received on the other end and reassembled, and we expect it to be instant. Now, take a video and then it's streaming that. Holy cow, that's insane technology, right? Like, who thought of this stuff? Well, a bunch of really clever people did back in the 60s. The guy's name is actually Jonathan Licklider, I think is his name, that came up with that concept of packet transmission. But the whole point is, all the information that travels the internet in a TCP packet has a from address, a to address, a checksum to make sure that all the data is correct. Like, how much data is there? This much. Okay, is it there? Yeah, it's there. And then the data itself. And it travels over the internet that way. I think it's an amazing concept and technology for sure. Everything that's on the internet that is connecting and talking to other devices on the internet all have a numeric address. So for example, if you type in this IP address, and you can try it if you want. Here, I'll put it in the chat if you really want to test it. This is Google's IP address. So if you copy that address and put it into your address bar and hit enter, it should take you to Google. Now, you would never remember that as a human being. And this is the problem with IP addresses, which is why they developed domain names, right? So nobody remembers 216.58.194.46. It's not going to happen, right? However, google.com, I remember, right? So the domain name system, which is that big database that's in North Carolina, its job is when you type in an address and press enter, it goes, oh, you're looking for google.com. Aha, this is the address, go. Right? It's like, so instead of having to memorize those, and this is really the Tim Berners-Lee thing once again, right? The problem was nobody could remember the addresses or how to log in. And then we have basically symbolic names that connect to actual resources. This is the real address. This is the one us humans use. Why? Because we would never remember this, ever. Well, a couple of us would. Right? I'm pretty good with like remembering some numbers, but man, could you imagine like if you couldn't visit anything on the internet unless you remembered the number? There was a time, believe it or not, back in the 90s that they used to have an internet phone book. Yes, Matthew.
So would that kind of, I guess in my head, it kind of reminds me of almost how like when we code, it's like instead of coding in binary, we're coding with words and then the computer translates it into binary.
Yeah, precisely.
Okay.
And you know what? And that happens on every layer of computing. Computers speak ones and zeros. Humans speak alphabets and 1 through 10, you know, or 0 through 9, actually, technically. Yeah, that's not a bad analogy. I like that. Now, here's a couple of interesting terms here, and I think at least the URL one might be on the quiz or a test coming up in the future, so I'm just kind of pointing that out. But we have what we call a URI and a URL, and typically a URL is basically a web page address, right? And you know, so really they're kind of interrelated terms. The URI basically identifies a type of resource, and the URL actually tells you where it's located. That's kind of the difference. But normally when we are in the address bar of our browser, we call that the URL. What's the URL? You know, and it could, what is it leading you to? Well, it could be anything, really. All right, when we look at the anatomy of a web address, right? And now our browsers, and I have to say this, most of our modern browsers obscure this part of it, the HTTP://. Right? The main domain name, by the way, is this part. So in this case, it says webdevfoundations.net. There's a subdomain that precedes it. In the old days, we used to use this a lot, www.whatever.com. But the truth is, to get to most websites these days, it's just whatever.com. That's the domain name. If there's something in front of it, we call it a subdomain, right? When we go past that and we have a slash, then we're entering, at least with the static HTML we're going to learn, it designates which folder the information's in and which file we're accessing. If the file is named index, you don't have to include that. Think about it. You go to coca-cola.com, you're not going to coca-cola.com/index.html, right? You're not doing that. That would probably work too, but index.html's default name for a homepage, and I'm going to hammer this one a lot, all lowercase, spelled exactly like that, no variations, and it automatically loads. Now, if I have a different web page called, Joe's page.html, well, then I would have to specify it because that doesn't automatically load. So that's kind of the anatomy of a URL. We do have what we call top level domains. So this is like what comes after it. So like .com is kind of like the big one, right? Everybody wants to have that. So if you have a business, you want your business.com. But we also have .org, .net, .mil, .gov, .edu. These are all the original top level domains, by the way, that we started with. Everybody on the internet had one of these, like back in the 90s. And then they started, running out of them. So like 2000s roll around and they start coming up with these like weird ones, these other more customized ones. And then what's happened is we have top level domains for every country on the planet. Every country on the planet has a 2-letter domain reserved specifically for them. Right? So what is it for the US? Well, .us. What is .uk? Well, easy, England, right? What's .cn, do you think? Yeah, China is correct, if that's what you were going to say. And then there's like weird ones like this, .tv, which you see a lot of people using .tvs, and it's this tiny little country in the Pacific, and I forget even what the country is called, but they make a living off of selling .tv domain names. Monica.
Oh, I'm sorry. I didn't realize I raised my hand. I'm sorry.
Oh, it was just a mistake? Okay, that's all right. All right, thank you. Rio, you have a question. Or did you do the same thing, Rio? All right, you're not unmuting. If you have a question, if you find the mute button, just go ahead and do it. All right, so I think that's kind of interesting. Here in the US, we tend not to use .us, but it is out there. And then what's happened in the modern era, frankly, is that you can get really weird top level domains. And one example I'll give you is we were working with a client once. This is part of a student project, and the lady owned a cafe up in Mequon, and she wanted to buy, the name of the place was onthewaycafe.com. That's what she wanted to buy, but it was already taken, right? And she's like, I want a .com. I was told I should have a .com. And I'm like, that's the old school way to do it. Like these days, how many people really type in web addresses? They really don't. They search and then they click on stuff, right? And so I convinced her that you should get .cafe. So on the way .cafe, and it was really the right move. Yes, Juan.
I actually learned a valuable lesson. So I personally did a website for myself, and I let the domain expire. And I was thinking if it expired, you could just rebuy it, but it doesn't work like that. It actually has to go into holding for a certain amount of days. And there's a chance it could get bought up, and then you would have to personally buy it back for a higher price if you wanted that domain name again.
Yeah, it's happened to me too.
Yeah.
And you know what? The holding period is 30 days officially.
Yeah.
Right. That you can, it's kind of like, hey man, I'm out of money. I can't afford to buy it right now, that kind of thing. So they give you a month. And then if you don't buy it, it's supposed to be released for sale again. Yeah. However, this is what's been happening lately. Often the companies that sold it to you, they'll buy it for a year, hoping that you'll come back looking for it because you're screw up or whatever. And then they're going to charge you like $1,000 for it. Like if you really need that. And if you already have a website running on it, some people pay it.
Yeah. So
yeah, it used to be a whole game, by the way, that people would go out there and buy domain names just to resell them.
Yeah.
It still happens, but it's very, very rare now. But some great stories. And here's a couple that like the Coca-Cola thing I always keep hammering on. That was owned by a private individual. Coca-Cola had to buy the name from him for millions of dollars. He was just a Coca-Cola fan. He bought it before Coca-Cola did. And then Coca-Cola had to pay him. And then Miller Brewing here in Milwaukee, same thing.
Oh wow, I didn't know that.
Interesting. And then later on there were lawsuits in some circumstances where, and I forget what websites they were, where people had the name, and then people argued successfully in court somehow that it should belong to them because hey, we're Microsoft, you're not Microsoft, we're Microsoft, and whatever. So the precedent is weird. I would say these days you get a name that's really cool, but don't worry too much about it. It's kind of a whole separate field of study, really. We do talk about, like, you see these like charts and graphs here, but you type in a domain name or URL, The domain name system converts it to a number. Then the browser goes to that numbered web server to request the page. And then the web server knows where that request came from your IP address, and then sends it back to you. It's kind of fascinating. So here's what I'm telling you. When you're typing a web address and then you press enter, that web server knows who you are. It's kind of interesting, right? They know where the traffic is coming from, unless you're like on a VPN or something, or some sophisticated hiding mechanism. So like if you hit a website, it's part of the record, and they got your number basically, right? Why? Because how do they know what machine to send the pages back to? It's pretty much as simple as that, all right, so let's talk about the languages we're about to learn and where they come from. Now, in the HTML, which is the first language we're going to learn here, is not technically a programming language. Some people think of it as that, and the course is called web programming because there's programming aspects to it. But really what it is it's called a markup language. A markup language basically means that we put stuff on the page, words, images, whatever, and then we create these special tags that encapsulate the content to tell us what it is. So for example, if I have a heading for a web page, I'll have, hey, this is my web page, and I have tags around it. That's markup. It says, okay, well, that's the title, so you know what you're looking at. Or, hey, this is a link, or this is an image, or whatever, right? The markup language. Now, the idea for a markup language did not originate with computers. Well, sort of, but not directly. It originated first with the printing world, because there was a time when we would print like newspapers and magazines, and they did it with real printing presses. And what they would do is they would hand set little pieces of type with all the words, and then they would ink that type, and then they would press it on the page. And this is like up until the late 70s, early 80s, folks. And then they started switching to electronic pre-press, where it would turn into a digital document and then hit the page to print. And they had to come up with a technique so that if an author wrote an article for a newspaper, and one thing was the title, one thing was the text, the other thing was like the abstract, and this was an image, that they could identify to the electronic prepress what that stuff was. So they came up with this language called Standard Generalized Markup Language that set up the whole concept of markup languages. And electronic prepress was done that way. And so then you didn't have to have people sitting there hand setting type, or machines setting it, or anything like that. It just became an electronic process. When we thought about putting stuff on the screen, somebody intelligently you said, well, we're still kind of creating content and we're publishing it, but it's just electronic. Couldn't we use the same approach? Like, this is a heading, this is bold, this is italic, this is small, this is large, this is green, that's blue, right? So that's what, HTML sort of is. So HTML originally was based directly on SGML. And then they came up with this idea later on that basically one of the problems with HTML is that it didn't have enough rules. And therefore, you'd put it in one browser and it would break when it worked just fine in the other one. And so they came up with XML, which gave HTML a little bit of a boost, in the sense that it came up with a strict rule set that we had to follow. And if you didn't follow, your stuff didn't work. And then because it was strict, now we could do things like that we could do with regular programming languages, is what we could make that web page do something because it's consistent and it's following rules, right? That kind of developed then into a hybrid version of HTML called XHTML. So this is really odd, but HTML basically went version 1, version 2, version 3, version 4. Then it switched over to XHTML for versions 1 and 1.1. And then when HTML5 came out, they went back to HTML. But the reality is all of it is actually XML, or an extension of XML. And it's part of the reason why the web is so powerful right now. So HTML5 also has versions. We still just generically call it HTML5. I think they're trying to do away with like numbered versions. I mean, technically 6 aspects of 6 are already out there and we're already using them. And I think they're going to make the move that they're not going to call version numbers officially, but technically we're still in HTML5 mode, but a lot of HTML6 stuff already works. Part of what made Google so huge in the early days is they were doing HTML5 before anybody else was. That's why their stuff is so much better. It's like, oh, this Google stuff works really great. You know why? Because they were using HTML5 before anybody else was. And it was really their large adoption of it that kind of moved it back over to the HTML rather than sticking with the XHTML versions. For a little while, there was a little bit of a war that we should have XHTML2 before we have HTML6, and I don't think that's going to happen. What do we use the internet for, folks? I think you guys already know that, but here's some examples from the book. Man, we use it for everything. That's really the reality. And we were in class today in the live class session, and we were just having this conversation, like, what would we do if the internet went down? Well, I wouldn't be able to work, right? Because everything I do is on the internet. I probably couldn't get to my money. Wouldn't be able to talk to anybody or interact with a lot of people, right? Unless I go out into the real world. So what do we use the internet for? Everything, right? If it shuts down, man, we're in trouble, right? I don't think a lot. It's like you turn off the power and you turn off the internet. Heck, you take away people's gasoline. We're going to be living like cavemen really quick.
Rude.
Right? Right. So what do we have to do? We have to make sure that never happens, right? All right. All right, so that was chapter 1, folks. What we're going to do now is we're going to take a 10-minute break because that was kind of a lot of lecture all at once. And then we're going to switch over to chapter 2. I will fire up the PowerPoints, but we're going to be coding. Before we dig into that, I'm just going to say also that if you don't have the software yet installed, please speak up and we can help you get it installed because it will be necessary for you to have an editor to work with. All right, so I'm going to stop this video here. So this video is over.